Okay, so we're gonna go in little spurts here instead of doing it all at once. So we're gonna check the number one answer. Will's gonna work it out for us real quick. If you're really comfortable with number one and you want to keep working forward, you can. If you want to stop and look at Will, go ahead and do so. All right, Will, so take us through number one. There you go. That looks good.
Okay, so for number one, it's asking us to find the amount of energy stored in the grain per square meter. And the formula is given here. So the first step is kind of picking out the numbers you need from this huge block of text here. So the first one is the solar energy. And then you'll find your 45% there. The EI, EC, and then the EP. And after that, you just kind of go ahead and plug that all in here. So we got the 2,500 megajoules per meter squared a year times the 45% times the efficiency of 0.7 times the biomass efficiency of 0.01 times the grain biomass of 0.6. And after multiplying all of that out, what were we seeing? 0.46? Oh, 4.7. Sorry, can't hear. Did anybody get anything else? That is what I was getting. So 4.7. And that would be in megajoules per square meter.
So a few people probably did get a slightly different answer. You got a different one, right? Jesse, you did, right? What did you get?
I got 5 point.
Do you know what was different in yours versus? Yeah. So you use the fraction of solar radiation available from the notes, right? And this one, and the reading they said was about 45. To be honest, we don't know exactly what that number is, right? So in this case, I would use the 45 like Will did in the number. It's okay if you use 48. This is the sort of thing where, like on an exam, if I see you use a number that makes sense and not exactly the one, you're not going to lose hardly any points at all on that. And actually, for the rest of this problem, you can keep going with whatever answer you want because either one is reasonable. Yep. Yep. Okay. So yeah, the point of this is not to debate that part. The point is to look at the energy cascade. So Will's going to show us the general formula for part number two. And one thing I'm going to point out while you write out the general formula, Will, some people are asking questions as I walked around. I thought we were calculating yield potential, but our units are in megajoules per square meter. Remember, yield potential can be in terms of energy, or it can be in terms of mass. We didn't convert this energy into mass. If we did, we would divide it by roughly 20 megajoules of energy are in a kilogram of the mass, and we would get a smaller number in terms of kilograms. But the rest of this problem is all about energy. So we're just going to keep it in the energy terms and move forward that way. So the general formula to calculate, this is one of those ones where we don't give you the formula because you should look at what you need. The answer is energy, and you should look at what you're given. You have a number in energy per person and a total number of people. You should be getting to the stage now where you see those kind of simple units and arrange the equation yourself so you get the units that you want. Sometimes it's kind of a straightforward thing where you just got to write the three things down and arrange them the way you need and move forward instead of always getting the equation. We're doing an in-class example, so we're going to give you the equation you need, but you should be able to start thinking through these units because they actually mean something, right? And help you solve the problem. So the total energy you need would be the number of people times the energy per person. And Will is rearranging the second equation to show you, oops, you bumped off of. The second equation to show the production equation or the pay equation saved for land area. So those are the general formulas you need in case you hadn't figured that part out yet. So go ahead and start filling in numbers and we'll check what you got for your answers here in about 2 or 3 minutes. Okay, so Will has the conversion that they need to start with. We calculated our yield from part number 1. That was in megajoules, but we're going to be talking about people next. So we're converting the megajoules into kilocalories. So Will has the conversion factor there, and he's gone from 4.7 to 239 kilocalories worth of energy being produced for each square meter. Now the question is, how many of those square meters at that level of yield do we need to feed a population of 7 billion people? So we'll go ahead and start filling in the total energy calculation too, so we can see that. Did anybody get anything different besides 1,129 or so kilocalories for the square meter? Is anyone confused about that step? We can go back. You're doing good. You have this one figured out already. Yeah, okay. Okay, well, we're going to ask a volunteer before you write the full answer in. Who has this part answered already, would like to share their answer with us? Multiplied across. Go ahead, Juno. Okay, so he said 5.1 times 10 to the 15. You can go ahead and write that down. We can check Juno's math, kind of mental math here real quick. So you multiplied 7 times 7 and got about 50, right? But 7 times 7 is 49. So 51 seems about reasonable with those things there. And then if you look at your exponents, you had 9 and 5. So you should have 14 plus the extra one you got from multiplying 7 and 7. So yeah, 15 seems like a good number. And that's how many kilocalories we need per year for the whole global population. Okay, so now the question is, how much area would we need to actually feed that population? So we're gonna substitute in the total energy needed, which is the number that Will just calculated there, divided by the energy per square meter that he calculated in the previous step, and calculate the number of square meters that we need to feed that many people just wheat. So go ahead, Will. Can you scoot your page up a little bit, please, Will? Oh, there you go. So our total energy needed was the 5.11 times 10 to the 15 kilocalories. Our yield from the previous calculation was about 1,100 kilocalories in a square meter. Make sure you keep your square meters there, Will, in the denominator. Kilocalories, square meters. Okay. Okay, so Will got, you divided 5 by about 1 and got 4 or something. Go ahead, Dawson. We should keep 2 the whole way through, and that's so to the 10th place the whole way through. That's right.
Yeah,
So-
that one's my bad. When I was doing this before class earlier, I was using more than 2.
So it would have been 5.11. That's okay. So you can keep the 5.11. That way, and we can get 4.52 at the end. That's good. So your units worked out okay, Will, but I would still write them out a little bit differently to make it easier, because you've got these ratios kind of floating around here, right? And it's kind of hard to keep track of what they are. So I would actually write out the formula like this: 5.11 times 10 to the 15 kilocalories. And then I would divide it by 1129 kilocalories per square meter, like that. So then your kilocalories cancel out, and you're left with per square meter, 1 over per square meter. That's the same thing as square meters, like that. So that's the way I would keep track of the units, a little less likely to lose them or get the ratios mixed up. But it's a little cumbersome to write it that way too. Okay, did anyone have a different number than around 5 trillion square meters? Okay, we're doing good. We'll go to the next step. So of course, we don't all eat wheat, although of the major grain crops, wheat would be one of the ones that's pretty easy to eat directly. You can make it pretty directly into food products based on flour and that sort of thing. Compared to like corn or soybeans, it's a little easier to eat those calories instead of having to feed them to an animal. But let's just say, what's number 3 about? Yeah, let's say for some reason we're feeding the wheat to the cattle. I guess it's not impossible to do so. That's not common globally to do. Let's say we have to feed it through a trophic level, right? So it's going to lose some of its efficiency by going through the cattle system. So let's keep the math going here. So take the amount of, if we fed the cattle, we would have a conversion efficiency of about 3%. So how many, calculate the energy a square meter of wheat provides to humans. So we're going to take the energy that we had before from the yield potential. So we got 1129, a little over 1,000 kilocalories in a square meter that was initially produced, like the graphs we've been showing. And then we multiply that. Go ahead and put kilocalories meter squared. Meters to the minus 2, yep. We're going to multiply that by 0.03, and we're going to come up with a number that is much smaller, 3% of that. So quick math on that one. Who has an answer for this one? Go ahead, yeah. Okay, very good. That sounds about right. That's about 3% of that number. Yeah, so 33.8 kilocalories. Showing up great. You're fine. Keep going. See if it works better. Looks better without the light. Okay. Kilocalories from a square meter. So we went from having over 1,000 to having only 33 kilocalories if you were to take the wheat, feed it to cattle, and then eat the energy from the cattle. All right. So let's redo the math here. Assuming that all the wheat is being used to feed cattle and humans only ate beef, how much land would be needed to grow wheat? Use the other assumptions stated in question 3. So we're going to redo the calculation from number 2, but instead of putting in our answer of, where's number 2? Instead of using our answer of 1,100 kilocalories per square meter in the denominator, we're going to put 33 in there. So we're going to redo this calculation from number 2 with substituting in 33. So why don't we just leave that up there for a minute so folks can see that. Substitute in 33 and tell us the new number that you got. I'll get the other one up. Thank you. Good idea. I love it. So I'm glad to hear people are starting to share. What we're going to do is I'll give you time to share now. And on Monday, we're going to talk about your discussion. So we'll bring it back up and give you some chance to refresh. So I want to leave time for people to be able to talk about the reading. One quick reminder again, we have a review session, 4:30 on Monday. I'll remind you in class on Monday. So finish up the reading and have a good weekend, folks.